prime factorizations of numbers. To make a tree for 60, first we look for two numbers that would multiply to make 60. They could be 2 and 30. Now, anytime we find a number that's prime, we'll circle it, and that'll be the end of that branch. But 30 is composite, so that branch can keep going. It splits into 2 and 15. There are other possibilities too, but all we have to do is come up with two factors that multiply to make 30. Now 2 is prime, so we'll circle that, but 15 is composite, so let's keep going. 15 is made up of 3 times 5, and both of those are prime. Once we arrive at all primes, we can't go any farther with the tree. If we did, all we would have is 2 times 1 here, and then that process could keep going forever, so there's no point in doing it. Now we'll write the prime factorization of 60. 60 is made up of 2 times 2 times 3 times 5. Every number has a unique prime factorization, and no other number will share that same prime factorization. Check out the tree for 24. Try it for yourself. Write the prime factorization of 24, and then I'll give my answer. So 24 is made up of 2 times 2 times 2 times 3. We can verify this with a calculator, and it checks. We can also write the prime factorization in what's called exponential form, where since we have 3 2's here repeated in a row, we can call that 2 to the power of 3, which means 2 times 2 times 2. And then we'll have a 3 to the power of 1, and that's another way to write the prime factorization. Here's a factor tree for 24. Now, if I were to complete the tree myself using a different choice of factors here, such as 2 times 12, would I get these same prime numbers in the end? The answer is yes. No matter how you break down the tree, if you do it correctly, you will obtain the same primes no matter what. This is an example of the fundamental theorem of arithmetic, or the unique prime factorization theorem, it's sometimes called. No other number than 24 will have these same exact primes. It's 2 times 2 times 2 times 3, or 2 to the third power times 3. Now sometimes we're interested in knowing whether a number we're breaking down is a perfect square or not. Sometimes we want to know if the number has a perfect square in its factorization too. These next examples will show a case where there is no perfect square inside a number. We'll see a case where there is a perfect square inside a number, and then we'll see a case where the number itself is a perfect square. So how do you tell from the prime factorization which is which? Well, here, the number 30 breaks down into 5 times 2 times 3. Notice that there are no repeated primes. What that means is the number contains no perfect square. Check out 24 though. It has repeated primes. There are 2 2's. And so this number is not itself a perfect square, but it actually contains one in its factorization. Here, the number 16 is made up of primes which are all duplicates. They all have a partner. So every prime is paired. And when that happens, the number itself is a perfect square. Try making trees for yourself of the three numbers below. Try to determine for yourself which one contains no perfect square, which one is not a perfect square itself but contains one, and which of these is itself a perfect square. All right, so if we take 70 here and break it down, we have many possible choices that we can use. Since 70 is even, it's common to choose 2. We know that 2 goes into any even number, so this will work out well. Just divide 70 by 2 on calculator. You get 35. Now, 35 is composite, but 2 is prime, so let's circle the 2. 35 would be made up of 5 times 7, which both happen to be primes. Now, are any of these primes paired? No. So, this number contains no perfect square. All right, let's try a tree for 45. 45 ends in 5, which means it's divisible by 5. So let's divide 45 by 5, we get 9. 5 is prime, but 9 is composite. We'll break this down into 3 and 3, which are both primes, but notice that there's a repeated prime. This means that 45 contains a perfect square in its factorization. What is that perfect square that it has inside of it? It is, of course, the 9. Now let's try 36. 36 breaks into 6 times 6, which would be 2 times 3 and 2 times 3. Notice that every prime is paired. All the primes are paired. So 36 is itself a perfect square. It's made up of 6 times 6. So these are 3 important cases that we're going to want to be aware of going forward.